A sample of nitrogen gas occupies 1.55 liters at 27 degrees Celsius and 1 atm atmospheres. What will the volume be at negative 100 Celsius at the same pressure? So this kind of exercises don't tell you what law you need to follow, okay? The exercise don't tell you. That's why you need to be smart enough and you have to read carefully in order to determine what law you can use. Now, let's take a look to the givens in this problem. It says that nitrogen gas, so we're talking about a gas, has 1.25 liters at 27 degrees Celsius. So, in the givens, I know that I have my initial volume, or my volume 1, to be 1.55 liters. Then it says that the temperature at which I have that volume is 27 Celsius. Okay? And then it says the pressure at that moment is 1 atm. Okay? Then comes the question that says, what will the volume be? That means that they're asking me to find the volume 2, the final volume. Okay? And to do that, they are giving me a temperature. Okay? So this temperature is going to be my second temperature of negative 100 Celsius. And it says the same pressure, which means that the pressure 2 is 1 atm. And again, I want us to analyze this. Now, take a look here. About the pressure, if your initial pressure is the same as the final pressure, this means that you have constant pressure. The pressure doesn't vary along time, okay? So, if you have constant pressure, and this is the most important part, okay? If you have constant pressure, what is the law that you need to apply? What is the law that you need to apply when you have constant pressure? Is it Boyle's or is it Charles? You can read from the presentation, okay? It is Charles, okay? Because Charles' law states that you can apply all those formulas, but under the condition that the pressure is constant, okay? Presión constante, okay? That's what it means. So, for this example, the problem doesn't tell you, use Charles' law. No, it's not, okay? But you have to understand that part, that if you don't have a change in pressure, it means that it is constant, therefore, you have to apply Charles' law. Another thing that you have to work with is the temperatures. The temperatures, as you can see, they are in Celsius degrees. You have to express that the temperatures, initial and final, must be expressed in Kelvin. So, your temperature 1 is going to be 27 Celsius plus 273. So this is going to give you 300 kelvins. The second temperature, which is negative 100 Celsius plus 273, is 173 Kelvin. Once that you have done the conversions already, okay, once that you have the conversions already and that you have defined what law you have to use, we need to finish the exercise, okay? So we say We are looking for the volume 2 using Charles, okay? So for volume 2, I have this formula, okay? So that's the exact formula that I'm gonna use for this exercise. So it says solution volume 2 is equal to volume 1 divided by temperature 1 times the temperature 2. Now we just plug in the givens that we have, and we say volume 1, which is 1.55 liters, divided by the temperature 1, that is, temperature 1 is 300 Kelvin. I repeat, temperature must be in Kelvin, and I have to multiply times the temperature 2, which is 173 Kelvin. With this, you're allowed to eliminate the kelvins with the kelvins, okay? So your volume 2 is equal to how much?
I got 8.89 liters. I think that's
0 point,
yeah, that one,
okay,
0.89.
0.89 liters. Remember, the only unit that you didn't cancel is liters, okay? So voila, that's your final answer. And this is the tricky part about the gas laws. I mean, it's not like the problem is gonna tell you, no, for this problem use Charles' law. So that's why we need to read carefully.